Hi. So about me, you heard the intro, 10 years in InfoSec. I started in 2005 at the University of Toledo. While I was out there, I went into regional government, writing custom MFA for terminal server, connection negotiation, data transformation, dependency detection, graphing. Went into grad school, later moved on to GM and then later OnStar within GM, working on connected vehicles. Then later changed gears, went over into the DoD space, working on embedded Android and Linux systems, and then all of the connector pieces to make that work together, mostly Yocto Linux. And then at the beginning of this year, I switched gears, moved over to back into cloud security, came over to Duo Security, which is a Cisco company, mostly async Python, JavaScript, and React. Actually, when I was applying for jobs is when I first learned about WebAuthn, or passwordless authentication. And at the time, I was taking a cybersecurity course in grad school, and I remember seeing this weird name on a job posting. And so I Googled it, and I went, OK, that seems pretty cool. And about 5 minutes into it, I said, you know what, I think I can write that. So this talk is based off of that work, cybersecurity course project, adapted into a broader discussion about passwordless authentication and then giving a demonstration. So our agenda today, why passwordless? A little bit about the history of authentication factors, passwords, and cryptography, really high-level stuff. Introduction of the FIDO standards and specifically the WebAuthn API. I'm going to give a demonstration of how these systems look to your end users, and then also how us as system developers get to build these systems out. We're going to discuss a little bit about system design considerations when you're building passwordless systems with WebAuthn. We're going to have some time for Q&A at the end. OK, so why passwordless? The big statistic everyone loves to talk about is the Verizon DBIR. 80% of breaches involve brute forcing or lost or stolen or poor quality passwords. That's pretty terrifying. So that's been a high number. It's actually gone down a little bit. Last year it was 81%. So good job, team. Why does this matter to me? Well, I really like this slide. I pulled it from somebody else's deck. I fight for the user, but also I am a user. I really like convenient. I really like secure. And so should you. So a little bit of history on passwords, because we have this addiction to them. And so why? It's an authentication factor, something you know. This dates back way to Roman legionnaires. Are you a friend or a foe? Do you know the password to get into the encampment? It's been the de facto computer security mechanism since the 60s. I think the first documented case I could find was the MIT timeshare system, which interestingly enough is also the first time that there was a leak. For passwords. In '62, somebody grabbed the password file, and keep in mind this is all clear text. This is before we knew to do hashing. Grabbed the password file because they wanted to get more access time to do more research work. Later in '66, the message of the day and the password files were swapped. So that's open-ended security there, right? And we've also been asking this question of like why we're using passwords way back to 2009. Some researchers at Microsoft published this work. Passwords, if we're so smart, why do we still use them? Over on the side, just some like quick examples of ciphers. We have the Caesar cipher table. We have a transposition cipher. That's a route cipher. And then this is actually an 1899 State Department codebook that's been since obviously declassified. Basically, for these phrases, use these numbers, so that's kind of neat. So discussing passwords, I really love to tell lay people, think of it as a time lock. This is really anything with security cryptography. It's a time lock. How long does it take for this information to get broken into? So when we think about passwords, we think about search space and online versus offline brute forcing timings for those, or attacks. I really like this tool, this haystack search. So even with what we would consider to be like a strong password, I mean, it's only 4 characters, it's very short. But upper, lower, alpha, like numeric and characters, That's an extremely fast offline cracking time. Also, I like to tell people, you can either have a random password or you can have a memorable password. And those are an exclusive relationship generally, so you got to pick. And then you have to rinse and repeat that for every new service. That gets pretty exhausting. So what do we all do? We use password managers. This generates impossibly long passwords for everything. And you encrypt this payload of all of your honeypots of passwords with one very strong password with some big hopes attached to that. I hope you don't forget it, because if you do, you lost it, everything inside of it. I hope no one copies that password or listens when you enter it. And I hope that password was actually strong. It doesn't do us any benefit to generate 32-character passwords if hello world is my decryption key for the whole locker. Later, we see the entry of multi-factor authentication. This is effectively defense in depth. So we know passwords aren't working. Something you know is not sufficient. People are not picking strong enough things that they know. So we have to also add something that they have or that they are. So now if I need to log into a system when something's down, shoot, where's my phone? Where's my YubiKey? So there's these additional things that put load on the user, but do secure our systems. There's a few different variants of this. There's voice and SMS 2FA. There's one-time passcodes, push for unlock. I really like that. And then certificate or public key infrastructure. Maybe even backed by a secure enclave or TPM. So don't use voice or SMS. This is absolutely trivial to hijack or phish. Couple bucks, you can redirect anyone's SMS messages to you. So not a good solution. OTP codes, kind of the same thing. Phishing's a big problem for those. Usually some sort of exfiltration or software on phones nowadays that can extract these tables. I love push. We do that at Duo. I think it's great, especially when you have additional monitoring or other tools in place so that you see who's accepting the push and at what times. I like certificates and PKI, obviously. That's WebAuthn, and we'll get into how that works. And it's even better when it's backed by secure enclave. By that, I mean a device, well, we'll get into it, I guess, on a later slide. Also, we have single sign-on as another option. This is what I do. This is my bread and butter professionally. And also, I'll talk a little bit at the end, how Duo specifically introduced passwordless and proliferated that into our systems. So single sign-on, we got two flavors available to us. We have social login, and we have other protocols like SAML or OIDC. Usually social login's backed by OIDC. Social login's the Wild West. I like to say, like, it's kind of Bruce Schneier's like data feudalism. You decide which organizations you want to trust with all of your internet access and history and records. So now if you use Facebook login, Facebook knows every website you ever log into and when. SAML and OIDC are generally only available to enterprise customers. It's really hard to write an identity provider, as we're working on right now. Over here, this is actually kind of neat. We've been building an OIDC identity provider for our Duo SSO platform, and we had a lot of interesting spin-up time as we're trying to figure out, like, which specs do we need to read? And I really like this diagram. It perfectly encapsulates everything we needed to learn in order to even ship just this protocol. So there's a ton of specifications for all of these. Okay, so back to secure keys, security keys. We see these a lot in multi-factor. So what are they? They're a secure enclave. They're generally tamper and extraction resistant. So the idea being the information stored in your security keys should be really, really hard to extract out of it. And you know, there are certifications for these products, and each vendor is going to do it a different way. They're all based on, or generally based on, asymmetric cryptography, which we'll get into a little bit more. They can also embed, that's supposed to say resident key credentials, which we'll talk about is basically not just passwordless, but also username-less authentication. Sometimes they're built in, your Touch ID on your MacBooks or on your iPhones, or your fingerprint and face unlock for your Androids. Sometimes they're peripheral, such as your YubiKeys, and sometimes they can be used to unlock even larger vaults. So you can imagine something like you Touch ID in to get a decryption key to unlock your hard drive. pictured over on the side, we see like the Google Titan key, Touch ID on an iPhone, and then YubiKey launched their biometric key this year. That's kind of neat. A little bit about cryptography. Asymmetric versus symmetric. Symmetric is same key for encryption and decryption. So that's a shared secret between both ends. When we talk about the CIA triad, confidentiality, integrity, and availability, symmetric cryptography only guarantees us confidentiality. So you need to know the secret to read the information that's sent over the wire. This is oftentimes used for securing data at rest or during a transport session, the data that's being transmitted. Some examples are DES, Trip DES, AES, Blowfish. Asymmetric's newer and cooler, I think. That's one key for encryption and one key for decryption. Generally speaking, like RSA and a lot of these, you can use the public key to encrypt. It can only be decrypted by the corresponding private key and vice versa, so it's reversible. That gets us confidentiality and integrity. So I can guarantee that the person sending it, depending on how they sign it, I can guarantee that they are who they say they are by virtue of they're the only people that should have that private key. RSA was published in 1977. It's named after RSA. That's the abbreviation for the, I can't remember off the top of my head. What I found really interesting when researching this was Ellis and Cox actually developed it in '73. This is a couple of GCHQ mathematicians, wrote the underpinning of RSA crypto, but that was classified because that's too important to let get out. So that was later declassified. These are used to secure those transport negotiations, such as like over the web. So when you do your HTTPS exchanges, you're usually doing PKI to negotiate a transport key that's symmetric. RSA, Diffie-Hellman, elliptic curve are examples. We use this every day for SSH, PGP, and TLS. Okay, so that's the super high level of crypto. Let's talk about FIDO. So this started when PayPal and validity sensors started talking about we really want to strengthen online shopping. By the time 2012 rolled around, the FIDO Alliance was founded. They had recruited a bunch of other companies. 2014 was the big first product of this. The Samsung Galaxy S5 had fingerprint e-shopping, and that was huge for us. Next year, FIDO 1 was published. Later in 2015, Bluetooth and NFC support was added. By 2018, FIDO 2 gets published. That's the specs we're going to be talking about. And 2019, we see there's a really wide adoption of that standard. The philosophy behind the FIDO Alliance: strong crypto over passwords and OTPs, limited scope. So think about that in terms of your cookies are usually bound to a domain. You are generally defining only a key pair for a specific service provider. And then device attestation is which devices do I want to trust? So I can actually specify if I want to do platform specific or specific vendors. Let's talk a little bit about the spec adoption. So we see a lot of green on this board, and that's good. We love to see that. That means support. So a lot of these systems, this is from 2020, so they didn't actually include any Linux stuff on there, which, right, what, who is she? Comes to a Linux con who doesn't have that. But, we do have this with libfido 2, so don't you worry. So wide browser support for the big ones and platforms. Okay, so FIDO 2 standard. That encompasses CTAP and WebAuthn. CTAP is Client to Authenticator Protocol. This is your hardware OS API and transport mechanisms to the hardware, between the hardware and OS. So these are system calls. Usually define transport mechanisms, is this a USB or NFC connection, low power Bluetooth, and then also how to communicate with the TPM devices. Web Authentication API, WebAuthn for short, is just for web applications. So this extends all of CTAP into your browser environment. So now you've got this JavaScript API in your browser, and then a couple of server-side libraries to make that all go on the back end. So system calls, think Windows Hello or libfido 2. Nope. Okay, so when I say this is a JavaScript API in browsers, this is it. These 6 lines is basically it, so that's the talk, right? No, but Anyway, so this is effectively what's going on there. We're going to dive a little bit into what these public key credential options, et cetera, are. High level, how this works for an end user is user is usually presented with some sort of that API call to create. User has to say, hey, I want to go ahead and do you want to create a security key for this service? User approves, usually does a fingerprint or enters a PIN or something. Key gets generated, and then information to register the key is sent up to the server. For login, it's very similar. The difference being you tell the server what your username is, and it tells you, here's some information about what authenticators are registered for that user, and then also here's a code challenge. That code challenge is then taken. User is prompted, do you want to log into this service, verify your identity as we see over on the side. They say yes, they go ahead fingerprint whatever your user settings are. We'll get into that later. And it signs that challenge information, sends it back up to the server where it can be verified against the public key that's been registered. Okay, so I have a couple demos here. Caveat, one on the left, that's an Android recording. Anytime the screen goes blank, that's actually the OS prompting me for my fingerprint. It won't record that. It's kind of a neat feature of Android, I think. So here's an example on WebAuthn IO. This is from Duo Labs. You guys can go out and do this yourselves. Most of your smartphones have this, as we saw in that previous slide. Yeah, so here's my prompt. I fingerprinted. This is only registering it as a platform authenticator. So now I can log in, fingerprint prompt again, and boom. And we get to see exactly the sort of information that's stored on the back end. So this is really just public information and identifier fields. The library we're going to be talking about in a little bit is the one that I wrote. This is on my personal site. So this one's OS X Chrome. Log in. I get to pick your YubiKey. Yep. Our setup, I have to enter a PIN to use my YubiKey. That's an additional setting you can apply on the browser. That's a neat little shim for if you don't have a password authentication available or a fingerprint or biometric or something. There's a way to verify that the user is who they say they are before they're allowed to encrypt. Okay. Okay, so high level of my demo, there's two pieces. JavaScript library, Django extension, and then a demo app to use the Django extension. But JS library is Axios with some CBOR interceptors. CBOR is short for concise binary object representation. Think JSON with encoding. That handles login and register functions. The Django module is a Django Rest framework extension. This includes some CBOR renderers and parsers, some base 64 in there as we'll see. Has a couple of models, authenticator and login token, some API views, and some very simple templates for testing. So let's talk about the Axios stuff. This is kind of neat. We define in our Axios client the CSRF token stuff that you would need to do for that support in Django. But additionally, we're registering these interceptors. That all those end up doing is check to see what your content type is on the request or response and decode or encode as needed, and you get back a JavaScript object. The login function is a big old wrapper for a generalized how to talk to WebAuthn function. But the super high level of calling this is you need a success callback, a failure callback, and your authentication payload. For a fully passwordless system, like my site, that's a username, my username. For a multi-factor setup, which you could also extend this to, that includes like password or OTP or whatever additional factors you want to include. Moving on. The registration looks very similar to this. That's why the generalized internal function is used for both of them. It's basically defining a slightly different callback to either get or create, and then how to translate the response that you get back. Okay, moving on. Also, please bear with me on a lot of these code samples. You guys can get the slide deck later. All this stuff's out on GitHub too. I just want to go super high level over it. On the Django side, we have two models. We have a login token. That's just a email reset kind of thing for initial registration. I need to be authenticated before I can register something, because you can't just take someone's word for it. I want their user IDs. The other model is our Authenticator model. That's basically just storing a nickname for the authenticator device, the public key information, base64 encoded, and a big text column, incrementable integer for how many times this authenticator has been used. You can detect whether a device has been cloned that way. For REST and for the REST side of things, I also had to implement some CBOR encoders and renderers. I also put some base64 stuff in there so that you can use the demonstration API pages if you're in demo mode for your server. But all these libraries are out there. They exist. They're nice, easy to use. This is just all glue. So each phase of authentication or registration is 2 requests to the backend. So it's not just a collect username and password, send it off, and get back an OK or a not OK. For login to function, we need to get that code challenge, as well as the identifiers for what security keys are registered for the user. So there's a login begin, part of that ritual. In this particular case, we're just looking up the user, pulling back all their authenticators if the user exists, and then report that back out along with a challenge. There is a passwordless backend that makes this all go in Django. Basically, when you register a authenticator backend, you can apply extra quargs on there that will make sure that your backend is the one that picks up. And that either returns a user model or it doesn't. At first glance, this looks pretty terrible, right? It's, all right, give me your username. OK, great, there's your user. Don't trust that. We can see in this demo page over here, Django Rest is really nice when you're in debug mode. You can just kind of use this neat web form. I think the Asymmetric stuff for Microsoft does something similar, but I like this better. But you can see base64 encoded, the challenge and the authenticator public keys coming back. So in this particular case, I'm trying to authenticate username Chris. And I can see that I have 2 public keys registered. We're going to talk a little bit about this, but that relationship between do I have public key or do I have authenticators registered or not is a bit of a username enumeration fault. So we'll talk more. Login complete. So now that I've got my code challenge, my user approves the authentication attempt. That's going to encrypt that challenge, send it back. So I give you the credential ID I used, the client data JSON, authenticator data, and signature. Signature is what's coming back out of the authenticator. And you get back a detail field that just says OK. And then your user information. So in this particular site, it's username, full name is staff. So let's talk some design considerations. So is this part of a, we really need to talk about the posture, security posture of your environment that you're deploying this to. Is this a system that's it's very important that people have multiple factors of authentication? You can include this as part of your multi-factor. If it's something that you're fairly confident that these security keys are biometrically enabled or something like that to make sure that there is that baked-in additional factor, you can use this for a completely passwordless system. So I think that's really important to just pay attention to what are your risks that you're taking on by adding this authentication infrastructure instead. Also, I mentioned before this resident key credential concept of username list. Basically baked into these systems, and I have a screenshot down here from Chrome, the authenticators can store the username information or details. And so you can actually tell the server, just use this ID for me. And then it'll usually keep a separate profile for you of name, email, all that stuff on the back end. But I don't even have to type in a username. That's pretty great. If you don't want to do that, some authenticators like the Google Titan don't support it. You can just set a cookie for username, generally speaking. That's usually a safe thing. So we also have some requirement parameters that we get to specify as system designers. I mentioned the discriminator on authenticator type. So you can specify I only want to support platform authenticators, or I only want to support YubiKeys. External authenticators we call cross-platform. Built-in we call platform. So think SE or TPM backed platform. Additionally, I can specify user verification. So you saw a PIN required in order to use my YubiKey. That is specified by the server to say that, no, just the fact that somebody clicked isn't enough. I also need to provide some additional things. So what are we doing here? We're pushing multi-factor off into the client in a way. And because of all of these systems of us saying, I only trust keys from these vendors, I only trust keys of these type or these built-in modules, we get to trust this whole chain. And as I mentioned, there's a biometric functionality for a lot of these things. And then also there's this attestation level. This is important because when you think about the certificates that are used to verify the authenticity of the vendor of the device so that I can trust that this is a YubiKey of this model and it supports these things, that's identifiable for the end user. So baked into the specification is this idea of we don't want this to be used to track you next. And I looked a little bit and I didn't see anything in the wild per se, mostly because WebAuthn adoption by server side is a little bit lower. But it's a design consideration of how much information us as system administrators need to know versus how much the user's allowing us to see about their devices. Oh, and I also really like this concept that Duo is going in with adaptive authentication. So you can kind of think about when we do multi-factor, paying attention to what are the conditions of an authentication event. Is this within the normal user behavior model that our system's trained against? Or is it something anomalous, authentication request from China? I should probably ask for more factors when the employee works in Ann Arbor. Oh yeah, wrong state to say that. All right, so some additional notes. I mentioned the username enumeration issue. This is a problem that you're going to see. Username enumeration doesn't necessarily matter unless we're talking about like email spam. When you're not being able to brute force an authentication, we trust that a 2048 bit encryption key is going to take until the end of the universe to crack for now. But when you think about these hybrid systems, as you sometimes see out there in the wild, where you can choose passwordless or you can choose multi-factor with a password, it's a design consideration that when you support passwordless, you also need to put additional security controls in to make sure that this system isn't used to look up, here are all the user IDs on the system. So just a thing to pay attention to. While we're on that note about good security practices, don't do what I did. Don't roll your own crypto or security. This was a term project. So it's out there, like feel free to use it, pick it up. It's a good example of how to use the FIDO 2 libraries. But I don't know, I use it on my dumb website. Like, don't use it in the real world. But use passwordless. Just use it from somebody that's smarter than me that wrote it. Django views an API to React is, I'm a web dev, and this is still really awkward to me. So this is more of just a note about that as I integrated these systems together. And I just kind of included these little screen caps over here because I thought it was neat. There's a couple different ways you could do this. I really like the Django. You can just dump a JSON blob in the middle of your template that comes back, or you do API requests back and forth. But I still think there's a better way that we can be doing this. I'm open for ideas if you have any. So with that, here are some resource links. So there's a WebAuthn 101. I really like that. That explains everything. The Duo demo that I showed you guys earlier from Android device, that's there at WebAuthn.io. FIDO Alliance, if you want to see, here's some identity provider libraries. Here's some certify providers. You can look those up there or more information about it. And then I have a couple of links here. This is my Django Rest Authn extension, and then also the React WebAuthn client libraries. Feel free, grab those, fork them, play around with them. So, questions? Oh, yeah, and if you have questions, please walk to the microphone and ask the question.
So on the topic of brute forcing usernames with that scheme, that's actually something I had written down as a question to ask before you even brought it up as a tip. I'm curious, you didn't actually mention how to prevent that. Obviously, there are things like CAPTCHAs, but that just means you have to pay people a penny for each username instead of preventing it altogether. So I'm curious what your recommendations are there.
Sure. That's a great question because as somebody that works in systems that use passwordless in a hybrid environment, trying to figure out how to protect us from that, I went and I looked at the spec and I said, okay, what do you specifically spell out here? And it says there's a username enumeration problem. You should pay attention to that. So there isn't actually baked into the spec or that a suggestion. I have sat around and thought a lot about the problem. Like, do I sample real user information and then send that back as a response for a known bad username? Like, because I can look up the user early on and say, is this going to be a successful auth path or not?
So like a red herring?
Yes, exactly. But so how much real information do I generate these things? Okay, so now as an attacker, I need to make 2 requests to make sure that it's actually the same keys that are coming back each time or something, because it can't be random per request. So I've got some ideas floating around. That's definitely more in my research bucket for later. But I don't have a good one. I just have a couple of strategies. We can talk more after. But those are kind of the high-level things I would do, is either sample real-life data that is deterministically looked up, or to generate sufficient spoof data that is also deterministically looked up or generated. Because again, you can't just send back a junk response, because if the attacker just F5s and get a different response, it doesn't tell anything. It just doubles the amount of time it takes to enumerate. Good question though, thanks. Next.
So I may have misunderstood, but if you're going for a general audience and you have no idea what hardware they have, they probably don't have fingerprint readers or anything cool like that. Are you basically just expecting to fall back to a PIN? Do you have better options than that, or?
Oh, like in the auth example where I used a PIN to provide the additional factor for.
Right, or.
Yeah, that's so far, that is the browser solution to things. Okay. Is to either call out to the OS for whatever the screen unlock protocol is, which would be for most smart devices, face unlock or touch ID or something. Or to fall back to a PIN. But yes, that's going to vary from browser to browser on how they want to polyfill that functionality in for you.
Okay, thank you.
Thanks. Additional questions? All right, thank you. If the code examples were not useful to you at all, at the very least, here are some cute pictures of my cats. But feel free to grab me after the talk if you have more questions. All right, thanks a whole bunch for your time, guys.